Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is your instructor Anisa Nawaz from Department of Physics. This is our lecture number 25 from chapter number 3, Forces and Motion. In the previous lecture we have discussed about multiple choice questions of chapter number 2. Right now we will start our next chapter, chapter number 3, Forces and Equilibrium, in which we will first discuss about concept of rest and motion, then vector nature of displacement will be discussed, and we will compare average and instantaneous speeds with average and instantaneous velocities, and after that we will discuss about acceleration and its types. Before discussing all these things, first we will discuss about the branch of physics under which we discuss the motion, that is mechanics. Mechanics is defined as the branch of science that deals with the study of motion of bodies. Okay, in particular it is the branch of physics which deals with the study of motion of bodies. We are having two types of mechanics. First one kinematics and second one dynamics. So mechanics is subdivided into two branches. First one is kinematics and second one is dynamics. In kinematics, it deals with the study of motion of bodies without making any reference to the force, cause of motion. Basically, if we are discussing the motion of the body in the branch kinematics, then we will not discuss the force. We will not discuss the cause of the motion. And if we are going to discuss about dynamics, then it deals with the study of motion of the bodies under the action of force and its various types. So first we will discuss the motion of the body under kinematics, and then we will move towards dynamics. Okay, so first we will discuss about the concept of rest and motion. We say that some body is at rest. So what does it mean? It means that if we are going to define rest, a body is at rest with respect to an observer if it does not change its position with respect to an observer. Okay, if a body is at rest, we say that it will not change its position with respect to an observer. There must be an observer who is observing the object, and that object must be it should not be changing its position. Okay, we will say that the body is at rest. If we are talking about the motion, a body is in state of motion with respect to an observer if it changes its position with respect to an observer. Okay, if a body is changing its you are observing a body and that body is changing its position, then we will say that the body is in motion. And if we say motion, it happens all around us. You can see different objects moving around you people. Okay, different vehicles are moving, we are moving, our body parts, they are moving. Okay, so different objects, different things which are present around us are in motion. One dimensional motion is the simplest form of motion. Okay, if the body is moving forward and backward, up and down, left and right, we will say that this is one dimensional motion. You can see over here, if we talk about relative motion, you can check over there. If the speed is the speed of ball different relative to the pitcher, the truck driver and the jet pilot, why or why not? You can see a ball is moving over here, an observer is here, a pitcher, a truck driver, okay, and the jet pilot. All three are looking at this ball. So whether they will observe the speed of the ball as same or different, what is the reason behind that? If they are checking out the speed is same, then what is the reason behind that? And if they are observing the speed is different, what is the reason behind that? Let's check that out. Okay, before that, first, motion takes place over time and depends on a frame of reference. means that what is frame of reference? Coordinate frame within which to measure position, motion or other properties of an object. So basically if we are selecting a place, like if we are sitting in a room, then that particular room will be our frame of reference where we are making the observations. If we are making the observation on the surface of earth and we are observing sun, then this whole earth will be our frame of reference. Okay, so any coordinate frame within which we are making the observation, that will be known as frame of reference. In Newtonian physics, all motion must be defined in terms of a reference frame. So all the motions must be defined in terms of a reference frame. We should be having a reference frame, because next we will discuss that the concept of rest and motion is relative to each other. Sometimes an object is at rest with respect to an observer, with respect to a frame of reference, and same object is moving with respect to some other observer. So there is you can say it is must to consider a frame of reference where with respect to which we are making the observations. Okay, so rest and motion are relative. Rest and motion depends upon the state of the observer. These two conditions, rest and motion, they are basically depending upon the state of the observer. Rest and motion are not absolute. We cannot explain these two terms separately. They are interdependent. Two observers can have disagreeing observation about the state of motion or rest. We are having two observers, and if they are talking about the same object, then one observer may be considering it at rest and the other observer may be considering the same object in motion. Okay, so like you can see the example, if an observer is present in the train, then with respect to that observer, the train is stationary. Okay, if the observer is present within the train, then with respect to that observer, train is stationary. But if an observer is standing outside, then according to him, this train is moving with you can say some velocity, some speed. So a same object is there, but according to different observers, according to one observer, the train is in the state of rest, and according to other observer, the train is in the state of motion. Okay, if the observer in the train, it is not he is not seeing the objects present around the train, it is completely closed, then according to him, the train is stationary. Okay, and according to observer outside the train is moving. So the concept of rest and motion is relative. Okay, it could be different for different observers present in different frames of references. Okay, if you consider about the earth, okay, right now consider your situation. You are sitting on a chair. Right now your speed is 0 relative to the earth. You are sitting on the chair, your speed is 0 relative to the earth, but your speed is 30 kilometer per second with respect to sun. Okay, right now you are moving with the speed of 30 kilometers per second with respect to sun. So again, there is the difference in the state of rest and motion. Okay, so concept of rest and motion is relative. Rest and motion could be different for different observers. Next, we will differentiate between distance and displacement. There are some terms that should be understood clearly for further discussion. Okay, so first we should differentiate between distance and displacement. You people must have concept of this thing, but we will discuss it with some other aspects. We will discuss this thing in detail right now. So first, if we are talking about the distance, length of the path followed by a body. Okay, we will consider the complete length of the path which is followed by a particular body, and it does not depend upon the direction. Distance does not depend on the direction. Okay, so if we are checking this out, you can see, we imagine an ant crawling along a ruler like this. Okay, you can see the ant is crawling along a ruler. So how much distance did the ant travel? You can see that this ant is traveling a distance of 3 centimeter. Okay, this ant basically is traveling a distance of 3 centimeters, started from 0 and ending at 3. And distance does not depend upon direction. Okay, this concept should be clear. And now if this ant is starting from 3 centimeter and moving towards 0 centimeter, again what distance did the ant travel? Again you can see distance is 3 centimeter. There is no change whether it is moving towards left or right, it is covering the same distance. So we can say distance does not depend on the direction. Okay, so does his direction change the answer? No, it is not changing the answer because distance is not dependent upon the direction. Now you can see over here the ant is traveling from 0 to 5 and then it is turning back from 5 to 3. So what about the total distance traveled? You can see the ant has traveled 7 centimeters, 5 plus 2. The ant has traveled 7 centimeter distance in total. Because it is independent of the direction, we will simply follow the path followed by the object, the body, or that particular whatever the body is, we will consider the complete path followed by that particular body. Okay, so right now it is 7 centimeter. But if we talk about displacement, it is simply the difference between an object's final position and its starting position. We don't have to follow the path. We will simply make the we will subtract initial position from final position and we will calculate the distance. Okay, it does depend on direction. Displacement is dependent upon the direction. So displacement is equal to final position minus initial position. Okay, you can see delta x is equal to x final minus x initial. So in order to define displacement, we need directions. That is important. Distance does not need direction and displacement needs direction. And in which direction, you can see we are having different examples like positive and negative direction, north, south, east and west direction, or we can specify the direction with the help of angles. Okay, different angles could specify the displacement. Okay, so if we are considering the example of distance, that is the ant walked 3 centimeter, and if we are telling about the same thing with the help of displacement, what we will say? We will say the ant walked 3 centimeter east. Now direction is mentioned with the distance. Okay, magnitude as well as direction is there. It is telling us about the displacement. An object's distance traveled and its displacement aren't always the same. These two are different things. Okay, if we are considering the example of displacement, let's find displacement. The object is the ant is moving from 0 to 3. Distance is 3 centimeter and displacement is plus 3 centimeter. It is traveling in positive direction. Displacement is plus 3 centimeter. The positive gives the ant a direction. Now if the ant is traveling from 3 to 0, what will happen? Right now distance is again 3 centimeter, but displacement this time is minus 3 centimeter. It is moving towards the negative direction. Displacement has direction, so we are mentioning that particular direction. It is equal to minus 3 centimeter. Now if we are finding out the distance of and displacement of this ant, you can see it is traveling from 0 to 5 and then again from 5 to 3. So what about the distance? That was 7 centimeter, but displacement is not the same. It is the distance between initial and final position. You can see initial and final position is having a difference of 3 centimeters. So if we say that we are having this ant starting from 0 and whatever the path followed is, it doesn't matter. It is now at final position is at 3. So displacement will be simply 3 centimeter. in this case distance and displacement is different. Distance is 7 centimeter and displacement is plus 3 centimeters. Okay, so distance and displacement are not always same. Now if we consider an athlete runs around a track that is 100 meters long and he's running it 3 times, then stops. Okay, you can see what is the athlete's distance and displacement. We will find out. He is running around the track. He will complete 3 complete rounds and the length of the track is 100 meters. So first let's find out the total distance traveled. Distance will be 300 meters. What about the displacement? Displacement is 0. Why? Because the starting and ending position of this athlete is same. He has covered all the distance, but he is coming back to its initial position. So net displacement will be 0 meters. Okay, there will be no displacement around the circular path, or when the body is coming back to its initial position, no displacement will be covered. Okay, so displacement and distance are two different things. Why? Because displacement is having a direction and distance is not having a direction. It is simply the path followed. Okay, so if we are going to define the displacement, it is the shortest directed distance between two positions. Okay, it is a vector quantity and its unit is meter. So what is displacement? It is shortest directed distance between the two positions. Let's consider the motion of the body in this way. Let's say that this is point A, this is point B, and the body is traveling from point A to point B. Okay, from initial position to final position. This is the path followed by the body. Now what we will do? We will draw a position vector for initial position. Let's say it is R1. Then we will draw position vector for final position, that is R2. Okay, but we need shortest distance between these two positions. So what we will do? We will draw a vector starting from R1 to R2, because this is the initial position of the body and this is the final position of the body. So this directed distance will be giving us the displacement, delta R. It is basically the displacement over here. So we can say delta R is equal to R2 minus R1. Okay, so R2 minus R1 will be giving us delta R. Okay, we can draw a vector over here that will give us minus R1, and delta R is equal to R2 minus R1, which will be equal to delta R. Okay, so it is basically the shortest directed distance from initial position to the final position. It is usually denoted by delta. Okay, delta X, delta R, delta S, delta L, or delta D with a vector sign, because displacement is a vector quantity. It is the shortest distance between initial and final point, and distance and displacement are not the same physical quantities. Keep this in mind. Okay, distance and displacement are two different things. Distance is scalar, displacement is vector. Distance is simply the path followed and displacement is the shortest distance between the initial and the final position. Okay, now we have to differentiate between another parameter, another physical quantity, that is speed and velocity. We have to differentiate between these two terms as well, just like we have differentiated between distance and displacement. So how we are going to differentiate between that? Speed. What is speed? Basically rate at which an object is moving. A rate means time. Okay, a rate at which an object is moving. So we can use the formula of speed, that is speed is equal to distance divided by time. Okay, S is equal to d divided by t. Simply, we are not talking about displacement, we are talking about distance. So speed is equal to distance divided by time. Like distance, speed does not depend on direction, because distance is the scalar quantity, so speed is also a scalar quantity. Okay, so you can see over here a car drives 100 meters in 5 seconds. You can see 1 second, 2 second, 3 second, 4 second, and 5 second. So what will be its speed? If it is traveling 100 meters in 5 seconds, then its speed will be distance divided by time, 100 meters divided by 5. So it is moving with 20 meters per second. Okay, speed is 20 meters per second. So unit of speed is meter per second over here. It is traveling 20 meters in a second. This is the speed. Again, consider an example. A rocket is traveling at 10 kilometers per second. How long does it take the rocket to travel 30 kilometers? You can find the answer. We are having the formula V is equal to S by T or D by T. V is equal to S by T, so time will be equal to S by V. Velocity is given and distance is given. We can divide these two and we can find out the time. You have to do this. That is simple calculation. Find it out. Rocket is traveling at 10 kilometers per second. Okay, so what we will say that we are having how much time? You have to calculate that. And a race car is traveling at 85 meters per second. How far does the car travel in 30 seconds? You can also find out the distance from the same formula. V is equal to S by T. Now separate out S. You also have to do this simple calculation. S is equal to V into T, velocity multiplied by time. That will give us the distance. Okay, you have to calculate. You can calculate distance, time or speed with the formula of speed. Okay, if you're talking about velocity, velocity is basically speed with direction. Its formula is displacement over time. Okay, speed with direction and displacement over time. So we can say simply velocity is speed with a direction, just like displacement is distance with a direction. So if we consider, again we are considering an ant. Consider motion of this ant like this. It is traveling in 4 seconds, 5 seconds. In 5 seconds it has traveled a total distance of 7 centimeter. So time is there, 7 centimeter time is there, distance is there, and displacement is plus 3 centimeter. So speed will be distance divided by time, total distance divided by time. 7 centimeters divided by 5 seconds, that will give us 1.4 centimeters per second. So what is the speed of this ant? That will be 1.4 centimeters per second. Okay, and what about the velocity? Velocity is equal to displacement divided by time. So we will divide plus 3 over 5. You can see over here, speed is different, velocity is different. Speed is 1.4 centimeter per second, but velocity is 0.6 centimeters per second. These two are again different things. So which one are scalar quantities, which one are vector? Scalar quantity has magnitude but not direction. So distance and speed are scalar quantities, and you know that vector quantity has magnitude and direction. So displacement and velocity are vector quantities. What about average speed? It is the total distance traveled divided by the time interval. And average velocity, total displacement traveled divided by the time interval during which the displacement occurred. Okay, for speed we have to use distance. For velocity we have to use displacement. Okay, average speed is distance over time and average velocity is displacement over time, change in position over time. Okay, so this is the difference between speed and velocity. In speed distance is used, in velocity displacement is used. Speed is scalar and velocity is a vector. So mathematically we can say velocity is equal to displacement over time, or velocity as it is a vector, so we will use an arrowhead over here. V is equal to final distance minus initial distance divided by final time minus initial time. Okay, or it can be written as velocity is equal to delta. This delta means change. Delta is telling us about the change. So right now we are finding the change in position, final minus initial position. So this delta S means final distance minus initial distance, and delta T means final time minus initial time. So this is the mathematical formula for average for velocity. Okay, and if you're talking about average velocity, that will be equal to total displacement divided by total time. This is the symbol of average. Okay, this is the symbol of average velocity. It is total distance divided by total time taken. Okay, what about constant or uniform velocity? If velocity is not changing with the passage of time, we will say that it is constant or a uniform velocity. And instantaneous velocity, the velocity of an object at some instant or specific point in its path, and it is provided by the slope. We will consider this thing when we will discuss about the graphs. Right now focus on this thing, that instantaneous velocity is the velocity of an object at some particular instant, just for a moment. Okay, if we are considering velocity just for a moment, that will be known as instantaneous velocity. Okay, you can see the body is moving, and if we are considering its speed at simply at a particular position, that particular position it will be giving us instantaneous velocity. And if it is moving with constant or uniform velocity, then instantaneous velocity is equal to its average velocity. Okay, that point is important, that if the body is moving with constant or uniform velocity, then average velocity is equal to instantaneous velocity. Mathematically, instantaneous velocity can be written like this: vector v is equal to limit delta s over delta t. Limit average velocity, we are applying a limit delta t approaches to 0. What does it mean? It means that we are taking extremely short interval of time. We are taking such an interval of time that it is almost equal to 0, because by definition we have explained this thing that instantaneous velocity is for a particular instant. So time is decreasing to such an extent, we are applying a limit that time is decreased to such an instant that difference in time is almost 0. That is simply an instant. Okay, so we are applying limit delta t approaches to 0. It means that very short interval of time, delta s divided by delta t, that will give us instantaneous velocity or velocity for a particular instant. Okay, now if we discuss about the concept of acceleration. What is acceleration? These are simple terms that you people should be very clear about. Okay, acceleration can be defined as the measure of change in velocity with the passage of time is called acceleration. Measure of change in velocity with the passage of time, it is known as acceleration. Or another definition could be time rate of change in velocity is called acceleration. So acceleration is equal to change in velocity divided by elapsed time. A symbol of acceleration is A, vector is equal to change in velocity. We are talking about velocity, so that will be the vector divided by elapsed time. Okay, mathematically we can say that acceleration is equal to final velocity minus initial velocity divided by final time minus initial time, change in velocity. And as change can be represented by delta, so we can write this equation as acceleration is equal to change in velocity divided by elapsed time. Okay, how much time has passed. So this is the formula of acceleration. And if we are talking about average acceleration is equal to net velocity divided by total time. Okay, average acceleration is equal to total velocity divided by total time. Okay, this is the symbol of average acceleration. So we will take total velocity divided by time, simply the given velocity divided by time, that will give us average acceleration. Okay, if we define constant or uniform acceleration, by name it is clear that a body is said to have uniform acceleration if its velocity changes by equal amount in equal intervals of time. We will not say that velocity is not changing. If we will say that if velocity is not changing, then acceleration will be 0. There will be no acceleration. We have to say this thing that a body is said to have uniform acceleration if its velocity changes by equal amount in equal intervals of time. Okay, for example, if its velocity is changing 1 meter per second in 1 second, then after 2 seconds it should be 2 meters per second, after 3 seconds it should be 3 meters per second, like that. Okay, so if the velocity is changing by equal amount in equal intervals of time, that will be constant or uniform acceleration. Variable acceleration is opposite to that. A body is said to have variable acceleration if its velocity changes by unequal amount in equal intervals of time. Okay, if velocity is changing randomly, for example, for 1 second it is changing 2 meters per second, for 2 seconds it is changing 5 meters per second, then it will be known as variable acceleration. Okay, then deceleration or retardation. Whenever an object is slowing down or magnitude of velocity is decreasing, we say there is deceleration or retardation. Okay, decreasing acceleration is giving a particular name, deceleration or retardation. Velocity and acceleration point in the opposite direction in this case. Velocity and acceleration are having different directions. Okay, velocity is always in the direction of motion, but acceleration may or may not be in the direction of motion. Okay, it could be opposite to that. So velocity is always in the direction of motion, but acceleration is not always in the direction of motion. So you can see over here, velocity and acceleration, at some places they are in the same direction and at some places they are in opposite direction. Okay, so over here you can say that when an object is slowing down, direction of acceleration and velocity is opposite. When the object is speeding up, the direction of acceleration and velocity is same. You can observe this thing over here. Okay, again this thing, that object slowing down, direction of, see, same, speeding up different, slowing down changing, and again opposite because it is slowing down. Okay, so you should keep this in mind. So positive and negative acceleration, it is not only due to speeding up or decreasing the speed of an object, but acceleration can be positive or negative based on whether the object is moving in positive x direction or negative x direction. Okay, so positive and negative direction is also affecting the acceleration. Up till now we have considered this thing that if the speed of the body is increasing, its acceleration is positive. If the speed of the body is decreasing, its acceleration is negative. But this is not the case always. If the body is moving in positive direction, then its acceleration, and it is speeding up, then its acceleration is positive. If it is moving in negative direction and its speed is increasing, still it will be having a negative acceleration. For example, you can see over here in first case, if you are having a car which is traveling and the car is speeding up, its direction, its velocity is in this direction, it is speeding up, then what will be the direction of acceleration? Direction of acceleration will be positive. Okay, because it is speeding up in positive x direction, its direction of acceleration will be positive. Now you can see over here, the car is slowing down, it is applying the brake. Then what about the direction of acceleration? It is opposite to velocity. Okay, direction of acceleration will be now this, opposite to that of velocity, because the car is slowing down, velocity is decreasing, it is having a negative direction. Okay, that was due to the speed of the car. If now we are applying the same in the negative direction, over here you can see the car is speeding up in the negative x direction. Although it is speeding up, but its direction of acceleration will be negative. Okay, acceleration is negative. Okay, negative x direction. And if the car is slowing down but it is moving in the negative x direction, then both negative will make it positive, acceleration will be positive over here. Okay, so what is happening over here, the car is moving in negative direction, negative x direction, and it is slowing down, still acceleration is positive because negative makes it positive. Okay, so it depends upon the speed of the car, that if speed of car is increasing, acceleration is positive, if speed of car is decreasing, acceleration is negative. But it can also be explained on the basis of positive and negative x direction. If the car is moving in positive x direction and it is increasing its speed, acceleration will be positive. If the car is moving in negative x direction and its speed is decreasing, then it will be having a positive acceleration. Okay, so positive and negative acceleration could be explained on the basis of two concepts, just on the speed and on the direction. okay, because acceleration is a vector quantity, so it is dependent upon two things, direction as well as magnitude. Over here you can see that velocity is constant but the car is turning, direction is changing, so acceleration will be produced in this case. We will not say that if there is no change in velocity then there will be no acceleration, because velocity is also dependent upon the direction. If the car is turning, its velocity is changing, so acceleration will be produced in this direction, okay. So this will be the direction of acceleration if the car is turning. You can also consider this example of free fall. The body is moving in the downward direction, then its acceleration is in the downward direction, but when it is hitting the ground for a moment, what is happening, its acceleration is changing its direction, but just for a moment. Otherwise what is happening, the body is having increased velocity and its acceleration is in the downward direction, okay. So we will discuss this case of free fall in detail in next topics. So if you have to do some work, okay, I would like to end my lecture with this specific quote over here. Then you have to take first step, you have to start your work, your task, then think about it, how to do analysis, do the analysis of that task, then do the planning, how you are going to accomplish it, how you are going to complete your task, then try, do again, keep on doing, never ever give up, then success will be yours, okay. So how you are going to do a task, start, think, analysis, planning, try, do again and keep on doing. Never give up is the key to success. Best of luck to all of you. That was all for today's lecture. Thank you so much.